Every AI agent runs on a harness. The loop that drives the model calls the tools and manages the state. The only question is whether you should be the one writing it. Let me show you what I've learned building a bunch of custom agents and what I've replaced my own spaghetti code with. Recently, we built a legal AI assistant called Marcus for lawyers to help them research Salvadoran law. Let me give you a real example of why RAG is so hard using questions our lawyers got asked in law school. Imagine a mango falls from your neighbor's tree onto your property. Who gets to eat it? Under Salvadoran law, you actually can't eat it. It still belongs to your neighbor who owns the tree. The answer is right there in the civil code. But paste all of the 300 plus pages into an LLM and it gets overwhelmed and tells you, sure, you can eat it. It forgets a fundamental civil law principle. Specific law overrides general law. To solve this, we designed an agent that uses retrieval augmented generation, RAG, where a sub-agent searches the entire legal corpus. Then another sub-agent reads the full text of the articles in the first agent found, and then the main agent summarizes the reply. In our system, the model doesn't remember the law, it retrieves it. So out of curiosity, I built the system 4 different ways. A custom-built agent loop, Google's agent development kit, using the Antigravity SDK, and using the Google Managed Agents API, which can use the anti-gravity harness internally. Let's walk through all 4, and more importantly, let's talk about when to use what. Let's start with our custom loop. When we first started working on this project, Google's agent development kit was not ready for production yet. So I did what everyone does. I built a custom harness all by myself. Or well, almost all by myself. I might have had another agent help me build this agent. Anyway, it was a massive 845-line TypeScript monolith called agentLoop.ts. It was part of my Nuxt backend, and this file was an absolute nightmare to maintain. It was structured as a giant asynchronous generator function, and because the loop was entirely hand-coded, I had to manually manage the entire LLM lifecycle. I had to handle streaming text deltas, manage token accumulation, write a custom history compaction to manage my context windows, and build a complex retry and remediation loop system. If the model had issues with tool calls, my loop had to catch the error, write a feedback message back to the model, and prompt it to try again. And malformed JSON and tool calls weren't the only things I was checking for. Our users are lawyers. A made-up citation is a fireable offense. So right inside the loop, I checked every citation the model produced against our database, and any that didn't resolve to a real law got sent straight back for another pass. I never trusted the model citations. I verified them directly in my code deterministically. That was our lifecycle. The tools were a different story. They were grouped by surface. Server tools in one folder, companion tools in another, client tools in a third. And honestly, that's fine because we still have to be able to read our code, right? But where it got really ugly was when I tried to modify a tool because the schema lived in one file and the actual handler in another. And worst of it all, to react to the agent's calls, I needed a nearly 200-line switch statement matching tool call names to functions by hand. Add a tool and you need to find it in one place, and then you have to remember to wire up the matching case in the switch, and then you have to keep the two in sync forever. And it gets worse. The whole thing was welded to Claude, and only Claude. If I wanted to use Gemini or a local model, I would have to rewrite the prompt template, structured output schemas, the tool calling format, and the response parsing all that again. And that was honestly the last straw for me. What I actually wanted was to give this whole thing away as a free public API, but locked to one provider, I couldn't do that. That's what brings us to Google's Agent Development Kit. If you haven't used it, ADK is an open source framework from Google that gives you a structured way to build agentic workflows with standard abstractions like LLM agent. Coming from my open harness, the decision was simple. The loop, the tool dispatch, the streaming, the model adapters, all of that becomes ADK's job now, not mine. And I don't give up control to get it. I still define the agent exactly how I want it. Sub-agents, callbacks, model swapping, in code or declaratively in a YAML config file. Before we continue, I need to mention something about the ADK here. As of July 2026, the ADK varies quite a bit across languages. In this project, I'm mostly working with the TypeScript ADK since I've integrated it with my Nuxt stack. The first thing the TypeScript ADK fixes for me was exactly that lock-in I just mentioned. It gives every model one shared interface, so my tools get declared once and just work, no matter which model is behind them. Gemini is built into the ADK. Claude and Gemma each needed one small adapter in TypeScript, about 140 lines for Claude and 100-ish lines for Gemma. Just a tiny bit of mapping to the ADK, nothing else. The Java ADK, for example, already ships with a Claude class built in, And the Python one has LiteLLM, a compat layer that makes any OpenAI compatible model like Gemma on Llama CPP almost free. The JS SDK hasn't quite caught up yet, but it will. With these tiny adapters, swapping the model is just a single line change. Pass in Claude, we return Claude. Pass in Gemini, we return Gemini. Pass in Gemma, we return a local Gemma model. The agent code doesn't change. Adapting for each model's SDK directly would be so much more code to maintain. And that ugly switch to handle tool calls from the model? Gone. Each tool that requires deterministic execution becomes a single function tool object that welds the schema and the execution together. Because every tool now carries its own handler, the runner dispatches straight to it. And there's no name to function switch to maintain anymore. Define the tool once, drop it in one array, and you're done. Nothing to keep in sync. And remember the citation check I'd hand-wired into the old loop? In the ADK, it collapses into a single hook after a model callback. It fires on the agent's output the moment it's generated. So before the turn is even done, I run a regex over the answer, pull out every citation ID, and look each one up in our database. If our code finds any citation that doesn't resolve to a real law, we stop and our code redirects the model to reevaluate. Same guarantee as before, but now it lives inside of the loop instead of being tangled through it. Something really cool about this is that this happens before agent loop exits. An invalid citation can get fixed before we return an answer to the user. The check feeds straight back into the running loop and drives the agent to correct itself. This level of custom programmatic control is exactly why you choose the ADK. We ran our old custom loop and the new ADK side by side, and in our evaluation, the ADK agent had a much higher task completion rate and near zero hallucinations. The best thing is, because it's just a framework, I also decide where it runs. I could stand it up as its own isolated service and have it reach out via MCP, or I can choose to embed it, packaging the agent, its tools, and our Nux server into one container on Cloud Run. Our tools act as our connectors, communicating directly with our database. But with great power comes great responsibility. So we have to deploy this, maintain it, keep dependencies up to date, and take care of it. But all of that, compared to the custom loop, it's still only a fraction of the code. No state machine, no switch, no adapters. And I gave up none of the control. The tools, the callbacks, the citation check are all still mine. It works and it was worth it. The one string still attached, whichever way I deploy it, I'm the one keeping it alive. But then I tried the Antigravity SDK and it honestly made me question how much of that I needed to build at all. So, the Antigravity SDK. One thing to make clear first, this is not the coding agent you might know, the Antigravity IDE or Antigravity CLI. The Antigravity SDK is a Python framework for assembling your own agent on the same base as the IDE and the CLI. You write the prompts, wire up the tools, choose the model. No UI, no editor, none of that. It's a framework. It's closer to the ADK really, but with less to build. No function tool objects, no model adapter, no runner. I write the config and read the stream that comes back. Text, dots, tool calls, and results, in that order. The harness isn't something I set up anymore, it's simply there. And in our system, that config is the whole trick. It points the same MCP route my ADK agent already uses, so the legal search, the auth, the database, all that stuff comes along for free. But MCP is just one way to give it tools. The Antigravity SDK also has a built-in toolbox with tools for things like file system access and shell access. It even directly integrates a Google search. And if none of that solves your issue, you can also directly integrate Python functions. In my app, I turned the built-ins off though because I wanted to focus on data retrieval from my MCP. But what I love the most is that the Antigravity SDK implements the agent skill spec, which means that our agent can intelligently load different skill MD files as it needs without overwhelming its context. This, of course, is not the same thing as a tool or an MCP, but it helps the agent stay laser focused on what it tries to achieve. Something else that's incredibly powerful is that the SDK isn't limited to a single agent. The SDK can run a roster of named sub-agents that I define, and with one line of config, it'll even spin up more sub-agent workers on its own mid-tasks when it decides that it makes sense. This is something you might already know from coding CLIs. That's it. Barely more than a bit of config and I've got a working agent, but it's a trade, not a free lunch. I write less than the ADK because the harness is fixed. I can configure what goes in, tools, skills, and even a roster of sub-agents, but I can't reach inside the running loop the way the ADK let me. The orchestration is fully in the SDK's hands now, not in mine. One other trade-off is the choice of models. Today, the Antigravity SDK runs only with Gemini. Gemma was announced in the launch blog post, but not available yet. One thing that didn't change is that this is still mine to host. Just like the ADK, I package it, deploy it, keep it alive. This could be in Google's Agent Runtime, Google Cloud Run, or wherever they decide to serve this. And my citation check, I can still run it, but only once the agent loop has finished and delivered a reply to my user. There is no after model callback here, no way to catch a bad citation mid-flight and steer the model. So I flipped the citation guarantee UX around. The agent finishes, then I validate every citation against the database. Clean run, and the answer gets a green check. We can tell the user that the answer is verified. A citation that doesn't resolve, I flag it right there in the UI, so the lawyer knows that something didn't go quite right. Then I can offer a one-button reflag that goes and prompts the agent to please fix the issue. Our bet is that the agent is right almost every time. On the rare miss, I surface it instead of silently correcting it. The approach slightly changes because of the philosophy of the Antigravity SDK changes. It is that we can trust the agent's output. That's where the future is heading. Agents are becoming more and more reliable. Over time, we will have a lot less hand-holding as these agent harnesses become more sophisticated. There's one last thing I want to show you: managed agents. Every version so far, custom agent, agent development kit, Antigravity SDK, still made me answer one question: where does this thing run? I was always the one packaging it and deploying it somewhere. Managed agents delete that question. The agent stops being a container I deploy and becomes something I declare. An API call. Google runs it in its sandbox, scales it, routes the model, and holds the session. I manage almost nothing myself anymore. In managed agents, we set a base agent that is run. We no longer select the model. In our example, we use the Antigravity base agent since it's basically an implementation of the Antigravity SDK handed to us by Google. What's cool about this is that we can basically reuse what we've already built locally for the Antigravity SDK. The building blocks are the same ones from the SDK, the MCP connectors, skills, and the system instructions. The difference is that you declare them through the Managed Agents API. They run on top of a base agent inside of Google's sandbox. We use the Managed Agents API to define an MCP connector in just a few lines, pointing to our legal search server. The API handles everything else: orchestration, model selection, context window management, session persistence, and scaling. The Managed Agents API basically lets me hand my predefined tasks to the cloud and tell it, get it done. It's a hard concept to wrap your head around, honestly, because we're still living in a world where agents make a lot of mistakes, but this line is quickly moving. The vision is pretty clear to me. These harnesses are just going to keep evolving and are already at a point where this kind of declarative approach is good enough for many, but not all use cases. So let's wrap this up. We can think of all of these things as a spectrum. On one end, our custom harness. You own every line, you control every token, but you also debug every edge case and write every adapter. Honestly, you should never build a custom harness anymore. In the middle, the agent development kit. It runs the loop for you. It gives you full control of the agent. You can influence it at every step and nudge it into the direction you want it to go using deterministic code. Choose the ADK when you need low-level control, like our citation-validation callback before the loop ends, or when you want to run local models on your own servers. Next, the Antigravity SDK. This one bets on the agent. You don't reach into the loop and correct it. You let it finish and verify after. Still yours to host, still next to your data, just far less of it to build. Choose it when the model's good enough to trust and you want the smallest code base that still lives in your own infrastructure. On the other hand, managed agents. Same idea, but it runs in Google's sandbox instead of your process, so it scales without any infrastructure from you. You can swap the base agent, but you can no longer swap the model itself. You bring the skills and connectors, and the platform handles the execution. Choose this when your agent's behavior can be described by its capabilities and you want to scale without managing infrastructure. For Marcus, the core still runs on the ADK, because the last 10%, the citation guarantee, matters a lot for a use case. But the managed agent is live as well. And as these harnesses evolve, the case for writing my own loop gets weaker. Today, we're still working on getting the free public version out there. However, the plan is to run it on Gemma in the ADK, because neither the Antigravity SDK nor managed agents do local models yet. And we need absolute cost predictability to offer something like this for free. But the Antigravity SDK announcement says it out loud. Gemma support is coming. the full agent runtime on open models you can run and fine-tune yourself. The line of what an agent can do keeps moving, which brings me to what's next. I'm going to take one of these managed agents, hand it to Google Doc, and a single go, and let it run itself, end-to-end, autonomously. That's /go, and that's going to be the next video. Subscribe if you want to watch an agent operate a document all on its own. The future of agentic architecture isn't writing better loops, it's defining better skills. Thank you so much for watching. Happy coding.